ngadep ke sini belum ada dewan.
Nanti fotonya dikirim kan?
Iya dikirim. Satu bisa.
Makasih ya Pak.
Buat dokumentasinya yang iya katanya HP-nya yang kelihatan sekali silent lah. Please take a seat. Mr. Candidate, you come from the committee which was appointed by the Council of Deans and that is charged with the task of examining both your dissertation and the thesis proposition submitted therewith. Professor, let me check. Middelburg from Utrecht University will open the examination, will open the discussion, and it's a pleasure to welcome him to our university. Yeah, there you are. There. Please, the floor is yours.
Thank you, meneer de rector. Meneer de promovendus, I've read with very much pleasure your thesis. It's a very interesting topic about the heterogeneity of seagrass meadows, which we all see if we are diving or looking at a movie of seagrass meadows, and it has a lot of ecological implications. And you are now more involved in environmental policy, etc. And one of the things which was a new thing to seagrass ecology is blue carbon sequestration. So my first question is, what are the most important processes sequestering carbon in seagrass meadows?
Ya,
hooggeleerde opponents. Thank you for your questions. I would like to address your questions related to the carbon sequestrations of seagrass. As you know that in my first chapters of the seagrass introductions, I was explaining that one of the functions which is quite vital for the seagrass is to sequestrate carbon, so to capture carbon. So for this process, seagrass will take the carbon during the interactions with the hydrodynamic conditions. So based on that functions, I believe that the interactions between the hydrodynamics and seagrass could play a major role for this carbon sequestration at the first phase.
Okay, so if I understand it well, you're saying that the particle trapping by seagrass meadow is the most important process for sequestering carbon in seagrass meadows.
Yes.
Okay, that means that all the carbon they fix is not so important. Their own seagrass material production.
Could you please reformulate?
So elsewhere in your thesis you write that seagrasses have a very high primary production,
Yes.
and they produce organic matter,
Yes.
and that part of it is also accumulating in the sediment, isn't it?
Yes.
Is that more important than the particle trapping from external, or is it similarly important?
I think it's similarly important because there are two sources for the nutrients uptake by the seagrass, which is the one existed under the sediment, and then which is the one who is existed in the water column. The exchange process of this carbon, the exchange process of the nutrient from the water column to the pore water and vice versa, becoming the important major role for the seagrass to uptake nutrients.
Okay, so it's very good you make yourself already the connection between carbon and nitrogen. And my next question is about the nitrogen. So if you compare a seagrass meadow on muddy, silty sediment,
Yes.
or one which is on coral sands, very coarse sands, where would you expect that the nutrients will, say the seagrasses will sequester more of the nutrients via the leaves or via the roots?
Yeah, thank you very much. That's a very good question. So I explained the detail of the effective pore water exchange of the nutrient from the pore water into the water column and vice versa in chapter 4 and chapter 5 of my thesis. And I think both nutrient which is existing under the substrate is also have the same importance with the water column which is existed in the water column. So the effective pore water exchange to get the nutrients from the sediments in the water column and vice versa is becoming important role. And to add and to support that arguments, in my chapter 4 of my thesis, I'm explaining that in the leading part of the first leading edge of the patches, the nutrients was taken higher compared to the downstream part of the seagrass patches. And we are calculating in more details through the interaction with the hydrodynamic, the maximum conditions, the transitional zone of the turbulence kinetic energy which is existed inside the patches.
Okay, so if you talk about nutrients, you can talk about dissolved or particulate, organic and inorganic. So what is most important for seagrass meadows? Is it dissolved or particulate, or is it organic or inorganic? Is there anything to say about this?
Yeah, thank you for your questions. In my opinion, that it depends on the nutrient uptake rate of the seagrass. If the nutrient uptake rate of the seagrass was taken by the root and rhizomes, the particulate could become more important in this stage. But if the nutrient uptake rate was taken by the leaves, the dissolved oxygen or the dissolved nutrients will be taken by the leaves. So it will be very dependent on the ecosystem of the seagrass where they are existing.
Okay, thank you. May I? Do I have some time?
Yes, there's still some time.
Okay.
left.
Okay, then I would like to do something completely different now. That's still in your thesis. So on page 13, you write, you summarize at the bottom. You, according to Santos from Southern Cross in Australia, there are at least 12 mechanisms that drive pore water exchange. Then we're going to the end of the thesis at page 98. You still cite Santos. You only have 7 mechanisms. So I presume that 5 have dropped out during the study. So from those 7, which are the most important ones? Because from those 12, if you go from 12 to 7, you already made some choice based on your scientific knowledge which you gained during those years you worked on this. So from those 7, which one would you recommend to us to further investigate?
Thank you very much for your questions. During my thesis, I studied that there are several processes which is related to the pore water exchange of nutrients or dissolved oxygen, whether it's coming from the water column or whether it's coming from the sediments. And in my chapter 4, I explained in more details the influence of the horizontal pressure gradients, which is existed as one of the main factors to conduct this pore water exchange. So between these 7 components which is related to the pore water exchange, I believe that all 7 will play important roles to exchange nutrient from the water column into sediments or vice versa. But because I did it in my thesis about horizontal pressure gradients, I believe that we can do more investigations on the horizontal pressure gradients as the main factor for the effective pore water exchange.
Okay, thank you. Thank you, meneer de rector.
Thank you very much for your participation. Discussion will be continued by Professor Hoekstra from Utrecht University. It's a pleasure to welcome you to Leiden and to the ceremony. The full rules.
Thank you, meneer Director. My questions will be going about chapters 2 and 3, especially about the experiments that you have carried out in a very nice way with different setups and with different boundary conditions. My first remark is a bit about the turbulent kinetic energy that you use and the way they expressed it in the thesis. You do it differently in chapters 2 and chapter 3, and I find it a bit confusing. I think there are some brackets missing in some of the equations. So, but I won't bother about it. I suppose that you have corrected that in the computations, and that the computations are correct. Okay, my first question is actually about the figure number 2.2 on page number 33. There you show the nice pictures which you have been measuring with the acoustic velocity meter. And there you draw a red line, which is the difference between the canopy, more or less, and the area above the canopy. Can you tell me, because I have been looking to that, but I couldn't find it, what did you use as criteria? What is flow through the canopy and what is flow over the canopy?
Thank you for your questions. I would like to address your questions about the figure number 2.2, about the turbulence kinetic energy. So this is actually the experiments where we are trying to determine or investigate whether the patch scale characteristic of the meadow is much more important than the meadow scale arrangements of this patch scale characteristic. So we are arranging into 4 different meadow scale characteristics. It's parallel, dense, sparse, dense, and also the checkerboard patches which we have used in this chapter 2 of this thesis. So we then determine the flow which is existed or passing through this meadow scale seagrass into 2 conditions. The one which is above the canopy, we call it the overflow, and then and the other one which is inside, we call it within canopy flow. So we divide the terminology based on the bending leaves of the seagrass patches. And this figure number 2.2 is using the velocity which is existed during the experiments to calculate the turbulence kinetic energy. And as you see that in figure 2.2 that there are certain pattern which is existed in this figure 2.2. I stipulated in my thesis that there is the tendencies of the turbulence kinetic energy will become higher in the downstream parts of the seagrass patches.
Yes, but my question is about what do you determine, what is flow through the canopy and what is flow through over the canopy? How did you distinguish it? Is it based on the velocity measurements or is it based on the position of the, let's say, the leaves, the artificial leaves? What is the criteria that you use?
Thank you very much for your questions. So we determine the flow over the canopy and the flow through the canopy based on the bending leaf. So everything below the bending leaf, we call it the true volumetric discharge, the true discharge.
Mm-hmm.
And then everything above the bending leaves, we call it the volumetric discharge. So we are defining or determining it based on the positions of the bending leaf.
So you have been measuring the bending leaves everywhere
Yes.
in this section.
Yes.
Okay, that's clear to me. Okay.
Yes.
The next question is about the experiments, and you'll be explaining about the geometry that you have been using and the different patches and looking at the meadow scale patterns. You use a patch length here of about, exactly 0.9 meters. What would happen with your conclusions? Because now you conclude that what actually starts above the canopy largely remains above the canopy. That's one of your conclusions, more or less, in the thesis. What would happen if you change the patch length? Would that conclusion still hold?
Thank you for your questions. So I think the impact of the patch length will become more clearance if we see or we cross-reference these conditions with chapter 4 of the thesis, where I'm trying to explain that in my chapter 4, as a cross-reference for this thesis, the patch length is 1 meter, so 100 centimeter condition, which is much longer than the conditions that we have in the first seagrass patches. So if we try to compare the conditions where the patch length is different, we can see that in chapter 4 of the thesis, we can see that there is a turbulence kinetic energy which is occurring at the back part or downstream part of the seagrass patches. So I believe that there is certain length that will influence the interactions of the hydrodynamic and seagrass patches. To support that arguments, I also calculate as a cross-reference in chapter 4 of the thesis that there will be an adjustment length where there is a higher transitional zones from the first leading edge into the downstream side of the patches, seagrass patches. So I believe that there is going to be certain influence on that.
And if you would change the patch length, if you would make it shorter, what do you expect then?
I believe that the adjustment length where the transitional zone which is occurring in the seagrass in the first leading edge of the patches will become much more higher, meaning that the equilibrium of the mean velocity will become also shorter or even happening after the seagrass patches.
Do we still have time?
Yeah, sure.
Yep.
Final question.
My follow-up next question is about the experiments in chapter 3. Let's take the diagram on page 48, figure 3.1. If we look at the setup of the experiments, you have these different patches that you use, different sizes and diameter within this configuration, and you measure the velocity along the center line of the flume, more or less. However, I expect that when you have these diameters which are varying, that also the flow in the cross-section won't be actually not uniform. So you're not everywhere you will have a same velocity. So my question actually is, if you look here at the distribution of your flow through the canopy and the flow over the canopy, how do you know what happens over the width of the flume in terms of refraction of the flow? Because the flow will respond on changes in depth, because that changes the friction, so it may also change the distribution of the flow over the width in the flume, and then you only have the measurements in the center line of the flume.
Okay, thank you for your questions. So we are trying to minimize the effect of the wall of the flume by trying to do the measurements in the center lines of the seagrass patches. I agree with you that there will be an effect of the seagrass of the flume wall if we are taking the measurements not in the center line of the flume. But the objective of this study in chapter 3 is we are trying to see the development of the flow based on different gap size within the seagrass patches. So we would like to know how is the influence of the hydrodynamic within the gap with different sizes. So that's the objective. And to get that sense of the objective, we are using the turbulence kinetic energy as part of the parameter to see how is the development of the hydrodynamic within the gap. So I believe you're right that there might be some effect of the flume if the velocity is not taken at the center lines of the seagrass patches. But to fulfill the objective of this chapter, I believe that we have already satisfied with the turbulence kinetic energy as one of the parameters.
Okay, thank you.
Well, thank you very much for your position. Discussion will be continued by Professor Kustiawan from Mula Varman University. It's a pleasure to welcome you to Leiden and to this table.
Thank you very much. So after you carry out some experiments, I would like to the question is, what is the most important things? I mean, important finding as the novelties of your research. Do you have idea how to transform the result of finding to the policy of conservation and restoration of seagrass, particularly in Indonesia?
Hooggeleerde opponents, thank you for your questions. I would like to address your questions related to the policymaking process of as a step further for this thesis. I have a very interesting experience. I've been working for 3 years in one of the governmental agency in Indonesia, and one of the responsibilities that we have is we need to develop a sustainable natural resource management project related to agriculture, forestry, peatland, and also we are responsible to install the renewable energy across the country. So I believe that in general, understanding the scientific process and get a good data and good analysis of several environmental conditions will help the policymaker to develop right strategy based on the scientific evidence. And it would be number one. Specifically related to the seagrass process, at the early stage of my PhD, my supervisor took me to Derawan in East Kalimantan. And the first time I see that there is a significant changes of the seagrass properties in Derawan in East Kalimantan based on the information from the locals that the existing seagrass, which is high at the previous year, now becoming really slow. So I believe that this thesis could provide a good background and good understanding on how the seagrass will interact with the hydrodynamic, and it will help the environmental manager to develop good strategy for the conservation.
Okay, so as we know that seagrass habitat has declined by several traits, including coastal engineering project, water quality and clarity issue, and boating impacts. In Indonesia, sometimes we are facing the conflict of interest. I mean, maybe some ministry like Ministry of Marine and Fisheries, Ministry of Environment and Forestry, and Ministry of Public Works. Would you please how to integrate the authority in sound coastal management?
Thank you very much for your questions. I believe that the Ministry of Forestry and Environment, and also the Ministry of Marine and Fisheries now is proactive coming to the communities to build awareness on how to preserve the ecosystems within the coastal. What may be still lack and can still be improved in the process is actually the larger participants of the academics from the university or from the research center to provide good understanding and good scientific evidence and good scientific reasons for the community, the benefit that the locals will have if they are conducting certain best practice. So I believe that that would be a good strategy for the governments to improve the environmental conditions and the coastal conditions in our country.
Okay, thank you. And the last question. In the thesis of your thesis, I mean the synthesis of your thesis, you stated that seagrass ecosystem can sequestrate carbon 35 times faster comparing with tropical rainforest ecosystem. And you also stated that carbon sequestrated in vegetated coastal ecosystem, specifically mangrove forests, seagrass beds, and salt marshes, we call blue carbon. So what do you think? We have to shift the tropical rainforest and also seagrass. That is, if you evaluate the policy of the government today, so it is, do you have, we have to change the regulation of what? Maybe you have an idea.
Yeah, thank you for your questions. As I stipulated in chapter 6 of my thesis about, I write it as the battle of the millennium,
Yes.
where the seagrass is going to be one of the heroes to battle this global changes in Indonesia and over the country, because this experiment was based on one of the research from a professor in Australia, where he is explaining that actually seagrass has the capacity and have the ability to sequestrate carbon 35 times higher than the normal vegetation. So the thing is only that this kind of information, supported by good scientific data, should be presented among the government, so the governments will understand the importance of the seagrass and how can they get the benefits of the seagrass or conservation, and then they can make the right policy, and then the policy could be implemented into the district level or even to the village level. So whether it's the seagrass or the forest, mangrove forest is important. I believe that both are important to conserve it. It's only about the different skills of the vegetations which can be provide good benefits for us.
Thank you, Prof.
Thank you very much for your contribution to this defense. The discussion will be continued by Dr. Sudzilovskaya from our own Leiden University. The floor is yours.
Thank you very much, meneer Director. Meneer the candidate, let me congratulate you with accomplishing this very nice, interesting research. I would like to ask you, you were experimenting with a seagrass made of plastic, so it is simulated seagrass. Could you explain what could be the artifacts or potentially missing issues due to this artificial experiment compared to the natural seagrass? So what could you have missed in your experiment?
Thank you for your questions. I'd like to address your questions about artificial seagrass during my presentations, during my thesis. So, as you know that it's been a bit difficult for us to get real life seagrass and then do the experiments in our nice bloom in years ago. So, to compensate that is we are trying to use the plastic seagrass as a mimic to simulate the natural conditions of the seagrass. So the length of the seagrass, the width of the seagrass, and the seed of the seagrass was based on the natural conditions of the seagrass. And also the density which we are taking from the normal seagrass mimic which is occurring in natural conditions. The only thing that we cannot mimic in this simulated seagrass is the roots and rhizomes. And these roots and rhizomes actually could improve our understanding about the nutrient uptake rate or the effective pore-water exchange. I believe that this could be a good starting point to do further investigations of the influence of the roots and rhizomes into effective pore-water exchange.
Okay, thank you very much for your answer. And I have another question. In chapter 4, you've shown that highest bromide concentrations in the sediment were at the edges of seagrass patch. So you actually show that seagrass itself prevents nutrient penetration into the center of the patch. So this suggests that different parts of the patch have different nutrition strategies. So the center of the patch takes more nutrients from the water column and edges of the patch from the pore water sediment. My first question, is it indeed true that there are different nutritional strategies in the nature? And if it is true, is it somehow reflected in the species composition of the patch, so there are different species growing in the center and the edges?
Yeah, thank you for your questions. As I explained that when we have seagrass patches and then there is unidirectional flow hitting the seagrass patches, we are using the Chen equations to calculate how much is the transitional zones of the turbulence kinetic energy happening when they hit the first part of the seagrass edges. So as you know that when the unidirectional flow was hitting the edge of the seagrass patches, there will be a turbulence at some level at the early part or the upstream part of the seagrass patches. And the turbulence which is occurring at the upstream part of the seagrass patches will become in equilibrium and become a mean flow at certain length of within the seagrass patches. We're using Chen's equations to calculate that, the adjustment length or the length of the transitional zones of the turbulence kinetic energy. So as we explained in chapter 4 of the thesis, we understand that there is some part where there will be highest penetrations of the nutrients at the upstream part of the seagrass patches. In our conditions, we say that at 0.19, which is fit nicely with the bromide concentration. Unfortunately, the condition